Hello everyone, in this video, we will present a real-life business case where mathematics plays a crucial role in solving practical problems. In today's digital world, business invents in various types of advertising to promote their products and reach wider audiences. These may include social media ads, billboards, and radio advertisement. However, understanding the individual cost of each type of advertisement can be challenging, especially when companies purchase bundle packages with mixed pricing. Our scenario revolves around a marketing agency that offers 3 advertising packages to 3 different clients. Each package includes a combination of social media ads, billboards, and radio ads. The total prices of the packages are known, but the individual costs of each ad type remain unknown. The main purpose of this study is to determine the unique cost of each type of advertisement. By applying mathematical techniques, specifically the matrix inverse method, by forming a system of linear equations based on the package details, we can represent the situation in matrix form and use linear algebra to solve for the unknown variables. This not only helps us find the exact cost of each ad type, but also shows how mathematical concepts like matrices are powerful tools in business decision making. Basically, this project demonstrates the real-world application of mathematics in marketing, pricing strategies, and financial analysis.
I will explain on the methodology of this case study. So the first step is that we need to form the system of the linear equation based on the given scenario that we have. Based on the 3 client transactions provided in the scenario, we can translate the purchase into a system of 3 equations with 3 unknowns. Client A is 5x plus 3y plus 2z equal to 8,500. Client B, 2x plus 6y plus 4z equal to 11,200. Client C is 3x plus 2y plus 5z equal to 9,150, where x is the cost of one social media ad, and y is the cost of a billboard, and z is the cost of the radio ad. This is the first step. So the first step is basically just forming the system of the linear equation. And then the next step is that we need to express the linear equation that we have formed before into a matrix equation. So we can simply just take the number out, put it in a bracket like this, 5, like the slide has shown, 5, 3, 2, 2, 6, 4, and 3, 2, 5, multiply by x, y, and z, which will equal to 8,500, 11,200, and 9,150. Okay, so the first one is actually matrix A that we have just get the system of the linear equation before, and now we will want to solve this using x equal to A inverse multiplied by B, and that's it for the first and second step. The next step is that we need to find the inverse of matrix A. So there are 2 ways to find the inverse of matrix. The first one is that we can use the calculator or using another software like Maple. The other one is that we can use manual calculation using any method that we know. I will explain briefly about how to use the software. This is the fastest method because we need to input the matrix A into the, as we can see in this slide, we put the input of A into the command, and we get A equals to 532, 264, and 325. And then we wanted to find the inverse. So we can simply, after we have put the input, we can simply just put A with the power of -1, which means that we are going to find the inverse of the matrix that we have put the input. And then we'll get the answer in the fraction unit. Let's say we wanted to get a decimal answer. We can use the same software, which is Maple, or we can use another tool that we wanted, maybe Symbolab or something.
Now, I'll be talking about the manual calculation for the previous questions by using Gauss-Jordan eliminations. Gauss-Jordan elimination is a method we use to solve system of linear equation or to find the inverse of a matrix. In this case, we use it to find the inverse of the matrix we have. Our goal is to transform the coefficient matrix A into an identity matrix I, while applying the same row operation to an identity matrix alongside it. We started with augmented matrix. By using the same augmented matrix, first we start by turning the first pivot 5 into a 1, so we divide row 1 by 5. Next, we eliminate the numbers below the pivot 1 in column 1, which is at row 2, we use negative 2 row 1 plus row 2 changes in row 2, negative 3 row 1 plus row 3 changes in row 3. Now, we make the second pivot into 1 by dividing row 2 by 4.8. Now, we eliminate the rest of the column 2, which is negative 0.6 row 2 plus row 1 changes into row 1, negative 0.2 row 2 plus row 3 changes into row 3. We now divide row 3 by 3.67 to make the pivot in the third column into 1. Finally, we remove the third column values above the pivot, which is negative row 3 plus row 1 changes to row 1, negative row 3 plus row 2 changes into row 2. The left side is now the identity matrix, and the right side is our inverse. This is our inverse. To get the value for x, y, and z, we must use the formula inverse A times B. Then, by using the calculations, we will get x equal to Rm 1,000 ringgit, y equal to 1,500 ringgit, z equal to 1,200 ringgit.
This result gives us meaningful insight into how advertising costs are structured for each platform. Despite the difference in client package, we were able to determine a consistent pricing model using metric inverse. The method we use, specifically the Gauss-Jordan elimination to obtain the inverse, is reliable and accurate. It not only confirms the value but also strengthens our understanding on how linear algebra can solve real-world problems involving systems of equations. This is especially useful in business environments where decision-making often depends on interpreting and analyzing structured data like this. In conclusion, this study successfully demonstrates how to solve a system of three linear equations using the inverse metric method. We begin by translating a real-world scenario into mathematical equation, structure it into metric form, and apply the Gauss-Jordan method to compute the inverse manually. By multiplying the inverse with the constant matrix, we were able to find the individual cost of each advertising service. This approach showcases the practical application of matrices in business analytics, especially in areas such as marketing, budgeting, pricing model, and cost allocation. Ultimately, this study highlights how mathematics, particularly linear algebra, can be a powerful tool for problem solving and decision making in professional industry.